Let's do another example of solving systems by elimination. So in this example, we have negative 7p plus 4q equals negative 9. And we have 5p minus 3q equals 5. And let me explain why I'm making the second video. Because this problem is more difficult when compared to the first problem. The reason it's more difficult is because we don't have, for example, we have a tough time making up our mind which variable we want to cancel, right? For example, what can I multiply 5 by to get negative 7? It had to be a fraction. Or what would I multiply negative 3 by to turn it into a 4? So I don't know a single value that I could multiply either equation by. So what you do in these cases is you actually multiply both. All right. So if you first, hopefully you notice what the issue is. The issue is I don't have one number that I can multiply to one equation. For example, I can't turn a 5 into a negative 7 by multiplying, right? What I can do is I can change both equations. So let's think right here of how I could work with, let's see, with this negative 7 and this 5. Well, negative 7, I bet I could turn a negative 7 into a negative 35. I would multiply it by 5. And I could turn a 5 into a 35 by multiplying it by 7. All right? So that's kind of crazy, but that's what we do. All right? Now, I'm going to multiply this whole equation by 5. That means left side and right side. And then I'm going to multiply this whole equation by a 7, left side and right side. So here we go. You have negative 35p plus 20q equals negative 45. Now, in the Desmos file on the left, I actually decided to eliminate my q's instead, which would actually is easier, but I wanted to show you that it works both ways. Okay, 7 times 5p will give me 35p. Hopefully you see now why I multiplied by 5 and by 7, because look at my p values. All right, they're going to end up canceling out. 7 times negative 3q gives me negative 21q. And 7 times 5 gives me 35. And that one's positive. So now when I combine my equations, all right, my negative 35p and 35p cancel out. 20q plus negative 21q gives me negative q. And negative 45 plus 35 gives me negative 10. So negative q equals negative 10. Divide by negative 1, so you get q equals 10, which is solid gold. All right, I've got q equals 10. Now I am going to substitute. All right, substitute. All right, so I can really choose whichever one I want. I'll just go with the first one. Negative 7p plus 4q, or 4 times 10, equals negative 9. All right, and I get negative 7p plus 40 equals negative 9. And I'm going to take away 40 from both sides. So I get negative 7p equals negative 49. In other words, p equals 7. All right. So my final answer in PQ format is 7, 10. I could verify this answer simply by substituting 7 for every p value and 10 for every q value, and it would work out. All right, final answer 7, 10. I'm going to check it right here with my old work, and indeed the answer is 7, 10. Now feel free to look at the Desmos file to see how I did it. I did it in a different way, still called elimination. I ended up in the first method that I solved it. For your notes, I multiplied the top one by 3 and the bottom one by 4. All right, which ended up helping me cancel out the q values. And I actually solved for p first, right? I found that p was 7. So all roads lead to Rome. You can cancel whichever variable you want, all right, as long as you do so with correct steps. All right, so to summarize, I multiplied both equations by a strategic number. All right, that number led for me to have opposite numbers in one of the variables. Then I combined, which led me to solve for a variable. I substituted, which led me to solve for the second variable. And I'm done.